Great to meet you all. My name's Sarah. I started a venture fund around AI a few years ago. But before that, I was lucky enough to be an investor in Baseten and have worked with Tuhin for the last 5 years. Maybe it's great to see all of you, but maybe I'll let Tuhin introduce Baseten first.
Yeah, it's been 6 years.
6? Who's counting?
Hi, I'm Tuhin. I'm CEO of Baseten. Baseten's an AI infrastructure company focused exclusively on inference. We help the fastest growing companies in the world run their models in production as performantly and scalably as possible. So we work with companies like Cursor, Bridge, Notion, Open Evidence, Gamma, Clay, amongst others.
So one thing I think is really interesting, we're talking a lot about like AI product experiences over the last day here. I think they're actually like quite slow, right? Like if you think about like waiting several seconds for like some of the most interesting experiences or the reliability issues that people see with AI APIs and products, like happens all the time. And that is not something you would accept from, I don't know, like the best consumer grade products 5 years ago, pre-AI. What do you like? How do you understand that? Do you think like performance matters today?
Yeah, I think performance matters greatly. I think, if you think about what is like the critical path to the application layer delivering value to all their customers, it's, hey, do the models work? One, base case. Oftentimes the models don't work.
From a quality perspective.
Second is like, do they work fast, which is, hey, how long does it take me to actually run this model? Like a good example of this is one of our customers. There's a customer called Open Evidence. 55% of doctors use Open Evidence every day, and it's a chat GPT for healthcare, and they expect answers fast. And if those models are slow, that's not super useful, or degrade their experience to some extent. And the third piece is, do they work reliably? And that is, hey, do these models not go down? So I think we in AI, to some degree, have somewhat of a high bar from a consumer perspective, but a low bar from an infrastructure perspective, of just because computers limited, running these models at scale is hard. But really, for the best products, they just don't go down. And that's what we're trying to drive to our customers.
I think one of the things that I've seen is just that it's partly because like people forget how insulated the entire software ecosystem has been from hardware and infrastructure issues increasingly over like, multiple decades, right? You guys were talking about like making sure you had the right CPU resources for an etcd deployment. And like, we don't worry in general as engineers about that today, except in AI, right? And so you have this like super immature ecosystem. I'm pretty confident that given how important the problem is and how many smart people are working on it, it will improve over time. It's also a really competitive space, right? So like the number of people who would say they do inference in some way ranges from obviously like proprietary model companies serving their APIs, companies serving, shared model APIs, dedicated inference, routers, like bare metal. How do you, people wanting to buy their own clusters and do it in-house as like an app company? Like, what is your framework for how people understand all of this and make a choice?
Yeah, I think it's very, very complicated. So I think you're right. Like, there's a hardware problem. There's acquiring hardware and using this hardware. There's a kernel level problem, which is how do you actually, get this to do math on that hardware very fast. Then there's the systems level problem that sits on top of that. And then there's a software level problem. I think really a lot of it, when you're choosing how to do inference, honestly, a lot of it is not driven by the providers as much as it's driven by where you are in your customer journey. So it's like, I think it's pretty normal where it's like, you experiment using the best, most expensive, most powerful closed source models. At some point, you're like, hey, I'm hitting rate limits. So you start using a routing layer to go between them. And then at some point, you're like, actually, this is too expensive, or I need some customization, or I need something special out of some model, or tool calling a certain way. So then you go and use a shared API for a open source model. Like the latest ones, like the Kimis, the GLMs, the QN family, and so on. And then after that, you're like, hey, I want to run this in my way. That's custom to the way that my customers need to use my application.
Mhm.
And that's when you go with something like a dedicated provider. And at some point, you just don't have enough capacity, and you're like, maybe I should go build a cluster, but you shouldn't do that. So I'd say, where we sit is on that shared and dedicated piece, which is, when you are looking to use open source models very, very fastly, in a very fast way, without having to stand up infrastructure, you come to Baseten. And then when you have very, very custom workloads, whether that means in the models themselves, so people running custom plans, user custom trains, or if you have a certain way to call it, you go to an inference provider like Baseten, saying I need customization. But that's really complicated. And I think like what we see is actually customers are pretty good at knowing when they need to make that decision on that curve. So like we can't go to our customers who are using closed source models and be like, you need to fine tune a model right now. They kind of get there themselves.
Mm-hmm. So they're going to run into, like as a developer, you're going to run into some sort of performance, reliability, capacity, cost wall, and then say like, actually, we need to go look at our own infrastructure.
Or like data privacy and security, or where can I run this, or even how fast can I run this, and then you'll go and find the different solutions. But I think it is very complicated. And I think everyone does a little bit of everything as well. But it's also a good place that you can choose as a developer to go and get best in class for that thing. If that makes sense.
I think a lot of people here were probably impacted by, this year's like GCP and AWS outages. You guys have decided to be multi-cloud in a pretty aggressive way. Can you talk about that, or like what you think long-term strategy for people will be here?
Yeah. So I think when it comes to running AI infrastructure, even Baseten aside, like what are like the key constraints? One's capacity, one's talent, and one's models. And then you put all those together, then how can you run those? I think for us, being multi-cloud, and I think most production systems at scale run this way. Anyway, it is it's a necessity, just because when you're running the most important workloads, the expectation isn't 3 nines or 4 nines. It's really just like zero downtime. And it's like you expect
that's fun as an infra provider.
Yeah, it's very fun. And so what that means is that when GCP goes down, we need to have other clouds that we can work with. When US East 1 in AWS goes down, we need to have failover in other places. So it's a necessity to be able to achieve that level of reliability. But I think it's also a necessity to be able to unlock the compute requirements of a lot of our customers. And so, what that means is that, when you need to spike really high, you can't just get 2,000 P200s tomorrow in the data center you want at the price you want it, on the term you want it, that you have to, be flexible there. But I think we can't just pass that on to our customers directly in terms of, hey, Baseten is the most flexible compute option for running inference workloads. And that is unlocked by multi-cloud to some extent.
So it gives you the ability to protect customers from some of the scarcity that happens pretty regularly.
Totally. And I think there's like a third piece, which I think will get more and more interesting, is, and actually it's pretty aligned with how Vercel thinks about this stuff, is, running stuff close to your customers. And what that means is that if you're an Australian developer calling a code complete model, you want to run that as close as possible to Australia and skip the round trip hops. And I think that's something else why multi-cloud and multi-region becomes very, very important. Being able to really quickly flip between which geographic, which data center is best geographically located to serve the user.
Yeah. So we've talked a little bit about how important performance is, both like what you get from an infrastructure provider and then just to the app experience overall. Like, what goes into that? What makes it hard? Yeah.
I think the biggest thing that makes it hard is it's immature. Like that's probably, it is software that is changing, model architectures are changing, models are changing, and the ability to run those very fast. You just need to be at bleeding edge all the time. So that is like the trend, the underlying trend is that it's a very, very fast moving industry, and running these things is being at the frontier all the time is very challenging. But I think more importantly, again, it's like 2 or 3 levels of problems. It's the infrastructure level problem, where it's like, how can I, go and acquire capacity to run this at scale to start with? It's something we try to help with. The second piece is, I'd say, the kernel level problem, which is like, how can I run this very, very fast on the GPUs themselves, and what frameworks can I use to do that? There's very limited talent to do this, but there's also like very limited open source options today as well to do this very well. And I think the third piece is just, as a developer, and this is probably what resonates the most, like, what is my interface with these things, and how can I have control over these things while getting frontier performance? So like, there's 3 levels of problems that all compound against each other, and then you're somewhere from a business perspective, you're on this kind of like cost and performance trade-off curve, and you just have to decide for your application where you sit on that, and then optimize for that. So it's 3 technology problems laid with a business problem. And I think thinking about that holistically is a very challenging thing. And we try to help our customers kind of think across that stack.
Yeah. You guys have some of the application companies that have the most maturity or most scale in the AI ecosystem. So I think you mentioned like Cursor, Open Evidence, Abridge, Notion.
Yeah.
What can you like project for people about like the decisions they make at what their level of maturity about how to do their inference strategy, and then also why it's not in-house for them?
Yeah.
In terms of your layer. Yeah.
Yeah, and it's evolving, but I think the biggest thing here is we're in like the AI.
If I just contrast that to like the foundation model labs,
okay.
right? They're very committed to, we're going to go buy a few $1 billion of chips at a time and do our own data centers, right? Including for inference.
Including for inference, and I think for them, it's like they have very proprietary models where they think they need to be very, very close to the inference stack to get that working. We're actually seeing more and more that's not the case, where like smaller companies training foundation models are like, oh, actually, we could probably, with the right flexibility from the right infrastructure provider, we can go use the best-in-class inference company. But I think the reason why some of those companies, which I would say are the best-in-class AI native companies, are using Baseten, is I think they're realizing that the way they do inference isn't particularly differentiated, and at least from like an infrastructure and performance level. Maybe like the way they shape their workload and how their model is trained is differentiated, but the actual inference stack isn't. Mm-hmm. And so I think what they realize is that, hey, how can we move as fast as possible? And the way to do that is abstract away the things that aren't particularly differentiated for you. And then, you realize as you start to build this thing yourself that you're going to run into all these hurdles. So like a good example of that is like we have customers who built the entire stack themselves on GCP, and we're like, oh crap, we have to be multi-cloud now. Mm-hmm. And it's like, why would I go and build multi-cloud when someone can do that for me? And the way that I do multi-cloud isn't necessarily any different from the next company that's going to do multi-cloud, the next app layer company that's going to use multi-cloud for their models. And so I think that is the biggest thing, which is like these companies all have one thing in common, is that they're optimizing for speed against like a very emergent market. And what they are outsourcing is actually, hey, what is going to unlock me to go as fast as possible?
Mm-hmm. And that's more likely to be application development work and understanding the customer, like or even model quality.
Yeah, I think it's how do you tie your workflow, your customer's workflow, to specific models, not necessarily how you run those models.
Mm-hmm. When you have attitudes around that changed over the last year?
I think so. I mean, you probably have a purview into this as well, but I think so. I think people are realizing that the best-in-class companies, they optimize for speed at all costs, and they optimize for the best thing across the stack. And so it's like, are you as a application company with limited resources, growing 10x year on year, going to have enough resources to make sure you grow 10x next year too, or are you going to go and take 4, 5, or 10 precious engineering resources to go and build internal Baseten?
Yeah, I think part of what made me very convinced that this was going to be like a durable layer that enabled more application companies is your point on like limited resources, and then a different one on just returns to scale, right? If even at the scale of the like fastest growing, biggest AI native app companies, it still makes sense for somebody else to negotiate with all 10 clouds at once.
Yeah.
Then like it feels like, you have to be a pretty extreme scale to make a different decision. And then the other is just, I mean, I know what our engineering like recruiting looks like in terms of getting amazing kernel level engineers, like model performance optimization people.
Yeah.
And I think it's hard for me to imagine that every great application company needs to go recruit those people too, right? It doesn't look like the application software ecosystem has benefited a lot from pushing that to somebody else.
Yeah, and there's just not enough of those people.
Yes. Like, well, and NVIDIA pays them super well. So.
NVIDIA, and so it's like, again, like, where do you, how it's I think it's a resource allocation question at the end of the day. And I think the other thing you said, which is right, which I didn't mention, which is like the scale that we're running at is like tens of thousands of GPUs every day, and at that scale, it is pretty. There's a scale structural cost advantage that we try to pass on to our customers that they won't be able to get themselves.
Mm-hmm. How do you think about like the? I mean, it could be small or it could be like traditional software companies, but the companies that are just getting started, right? At what point do you think about doing dedicated inference, and do you think they need a different product than people at scale?
Yeah.
Because you guys launched shared model APIs.
Model APIs, yeah. I don't think they did. I think look, we try to like support people like on every part of that curve, and we have shared APIs to start with. I don't think you need a different product there. I think when you're starting off, like, again, speed is everything, and yes, you should go and find a product like Baseten where you can find everything in one. But really, like, what you just need to figure out is what do your customers need, and what are the business requirements of what they need. Mm-hmm. And like I think we support a lot of that on that curve, but I don't think you necessarily need to, optimize. So, like, why would you go to a different provider? It's like, oh well, if they can do it faster than you or cheaper than you. And I think most providers like Baseten are pretty aligned with their customers. Especially we at Baseten is very aligned with our customers around, we will support you and figure out what you need at that part of the journey. And as the company scales, our business model evolves with you. So we will, again, optimize for what works for you about the journey.
There was one view of the world where you were just going to have essentially proprietary 1 mega model. They do all the functions. That has not been, as far as I know, your experience with Baseten customer. People have tens of models doing more specialized tasks.
Yeah.
Some of them, very large, very intelligent. Some of them more specialized.
Yeah.
What can you share? Maybe not naming the specific, but what can you share about what you're seeing in terms of diversity of models and where you expect companies to go in terms of that pipeline?
Yeah, I think this has always been like.
And we were just talking about somebody who is going to use, voice models, where I was like, that's different from their traditional business.
Yeah. I think there's a lot. I think there's a long tail.
Yeah.
There's a long tail of things. I think. Yeah, I think what we see in practice is many models specialized for the task at hand, and more, that task at hand might actually even include not only model capability, but model speed. Mm-hmm. So you might use a different model where you need very, very fast generation, and a different model where you're okay with something a bit slower. And so I think there are going to be many models for many use cases, and partly because it's just that it is not cost effective or reasonable to, you don't need a professor. You don't need a professor to solve if you're building a front end application.
Yeah.
The principles are very different, and so I think choosing the right model for the right job is right. I think with like the OpenAI launch, this was pretty clear as well, right? Where GPT-5 was actually like a bunch of different models under the hood, and that wasn't really the mega model, right? That was just like a router based on job at hand go to model. And so I think that seems increasingly how people are using it, models in the world. And I think what they're also doing is that for different parts of the user journey, they're choosing different models based on price performance trade-offs.
Yeah, and you're seeing like lots of different model modalities within the
for sure.
Base. It's not just like LLMs.
No. It's voice, image, video, embeddings,
voice.
And then LLMs, of course.
You mentioned that there are like open source runtimes and components of the inference infrastructure that are open source. Like, where has that been enough and not enough, and how do you guys address that at Baseten?
Yeah. At least when it comes to NVIDIA chips, NVIDIA's pretty good at running things on NVIDIA chips.
Mm-hmm.
So actually what we find is like in all the abstraction, all like the capabilities actually built in NVIDIA's APIs to some extent. And whether that be stuff like TRTLM or Dynamo, they actually have a really good serving primitives to interact with GPUs. I think where it's not enough is that NVIDIA software is hard to work with. And our view of the world is actually runtimes over time are open source, and there's not in the history of software, there's not that many proprietary runtimes that win in the fullness of time. And that is very much how we think about it. Right now, there's just like a bit of like a push and pull, and how do you get the open source runtimes to do what you want them to do? And that's where we try to create a lot of documentation, we write a lot of content around that, we build a lot of the abstraction into the software itself. But even the stuff we're doing, it's not necessarily like proprietary, but you can see we are almost showing you how to go and run this on NVIDIA chips as fast as possible. But we're just making it easier to do that. And so I think to the extent there are a bunch of closed source runtimes right now that are emerging, to me that's just like a blip in time when the market hasn't caught up to what the reality of like how developers want to use software is. I think what developers don't like is black boxes. And I think that which one's that?
One of the things that I was told is that you're not allowed to speak at this event if you don't say agents at least 3 times. So agents.
Yeah.
What are you seeing from Baseten customers about how the workload changes, or like how they should do inference differently for like the heavy agentic multi-call workload?
Yeah, I think it's actually.
You think it's the same?
I think it's the same. I think it just means
it's a dumb question. Okay.
It just means more inference.
Yeah.
And I think honestly, like the issue with agents is the hard thing about agents is that it can just get very expensive very quickly.
Right. I was going to say I from like being on the board of application layer companies, I see them treat it differently because they're like, well, we're going to make 300 calls every time the customer asks for this.
Yeah.
And it's like, therefore, much more expensive.
Totally. And so like what changes then is just like the cost and performance curve. I think when it comes to agents, you just start to think about it slightly differently. And you start to think it was like, hey, for this use case, is this okay? Or actually, we're gonna be calling this, and if we do it this way, there's gonna be thousands of calls to this model instead of 3. Like and the concurrency becomes a problem, and we need ways to batch these things, and we probably are okay with a performance hit to some extent. That's the interesting thing about agents right now is I think the performance of full agentic workflows actually matters a lot less than the individual inference call. And so you can be this flexibility that introduces.
But you still care about cost.
You care deeply about cost. Yeah.
Right. Okay. Maybe zooming out for our last few minutes, and I don't know if we're allowed to take questions here, but okay, I'm going to ask one question, and then I'm going to see if people have questions. Baseten, as you mentioned, reminded me, is 6 years old.
Yeah.
You've also gotten 7 or 8 times bigger this year as a business.
Yeah.
So it's been a big year too.
Yeah.
I think it is like a unique, amazing characteristic of this point in time that you can do amazing things that users want, and then the companies grow really quickly. You're a repeat founder. You've been doing this for a little while. Like what lessons do you have to share with people in startups about just like handling that type of growth?
Yeah. I mean, I think this is very AI centric. Like AI, like our company just is growing so much that it feels like a different company, like every 2 or 3 months. And I think that the biggest things would be like constantly reevaluate and like be first principled. To the market's probably bigger than you think it is, and at least for us, maybe that's an inference thing. But you can go really, really deep on problems. And I think the three things is that just anything you can do to just build speed into organizational design, like that has been huge for us. Like for example, we don't have a product function really. We have one amazing guy who does product work, but product is generally run by the whole engineering team, and they're just very close to customers, and like that's the way we try to be very, very fast with the market. And I think like we're hitting speed bottlenecks now as we're getting bigger, and the stuff that we see is not working is just because we haven't designed around fast decision making, fast feedback loops, and so that's one piece. I think.
What is the coordination function then? Because like what your biggest customers want is different, and you have a bunch of competing priorities at different layers of the stack.
Yeah, so again, we're lucky in that we can just be really close to the ground, and our customers just tell us, this is what I want right now. And I think what's interesting about Inference is like there's way more overlap.
Okay, maybe that's the like prevailing message here. You're like, actually, it's all the same. They
like
think it's different, but it's
very like there's like different business requirements, or like the different cost requirements. There's different developer workflow requirements where we have to make trade-offs. But the truth is, everyone just wants performant, scalable inference, and to power the best applications. And like that is what we need to be super focused on. And the coordination function for us is really, we have a forward deployed engineering team that is just very, very close to our customers, and they also they're also software developers. They spend time with customers. They close that feedback loop. They can pinch it into info if they need to. And that they're kind of like the glue that really gets everything going.
Okay, you had a question?
Yeah, Rachel, thanks for
Sorry, can you say your name?
I'm Axel. You can call me Ax. I love that you're paying on the multi-AI world. I work at here. It's an app to let you use all the latest models for free. So we definitely believe that there won't be like one single big model. I'm seeing a lot of open source models being like competitive with Frontier Labs model. Do you think that at some point the best models will be open source, or there will be like still like a niche for like Frontier models to always be the best? Like we have a leaderboard for like latest models based on user preference data, and right now it's still like always the models. So as you're building your company, people will use open source models. Do you believe that?
So
open source models can compete and will be.
So the question I want to just repeat it back is, the like how do we see the open versus closed source model evolving in the landscape over time? I think like 3 years ago, there was like a bet you had to make was that like, hey, open source is going to be competitive with closed source, and you really had to squint. I think like the first evidence we had of was like Stable Diffusion, maybe on and then Whisper probably is
Stable Diffusion, Whisper, then Mistral, then Llama.
And
then the entire Chinese families of models.
I think like even then, I think my answer would have been to you was like, why not both? Like and I think that is just the reality. Is that look, I think approximate quality will converge. So, and I think we're almost there, to be honest. Like I don't think we're 100% there, but I think we're like 90% there, to be honest. Which is like open source models can compete in production with closed source models at a fraction of the cost, and especially if you know exactly how it's going to be used, you can do that. But I think there's always going to be a place for people pushing the boundaries, and I do think that like open source is amazing, but closed source, like to be completely unbiased, like closed source and frontier model companies have a advantage that it's the same advantage that private companies have over public companies, is that they can do stuff without outside scrutiny, which just pushes them to be faster or be more adventurous at times. And so it's a really important part of the ecosystem. I think that they are continually pushing in strange ways, but I do think that open source is going to have like approximately the same value, and at some point, if that is the case, cost is going to have to converge as well. So.
Hey, I'm Maria, I'm one of the founders of Fellow. So we're seeing models get better, we're seeing inference get faster, cheaper, using some of the memory layer as well. I'm curious if you both are seeing interesting changes on the interface side or types of interaction models, especially when it comes to consumer that have
Yeah, and you mean like at the app layer? Is that?
After like different types of interaction paradigms.
Yeah. Do you?
Yeah, I'd say I think there's like a lot of very active work being done here, actually. And I don't know if people would consider this to be at the interaction layer, but because I'll give you one example. I assume everybody in this room has used like Cursor, Claude Code, Cognition, etc. The experience of having like type ahead autocomplete is a pretty magical one the first time you have it, where you understand like the cost of continuing to type is like not high, right? So sometimes it works, it's magical. And if you think about why that doesn't exist for non-technical audiences, it is because you actually need like much more context. Like if I think about when I'm typing an email or in any text box, right? Like I am probably keeping in memory a bunch of different things. Oh, Tuhin just asked for an introduction to this person, or my school's teacher asked me to like come to this thing, and like I need to put it on my calendar, right? Models can understand context from different applications, but they need like memory layer, and they're going to need really fast inference to process it, like to represent it in a way and process it quickly enough to like give you that experience, right? Because if you're an engineer or a human being at like 120 WPM and it's not keeping up with me, then it's not useful. And so I think there's a combination of model work in terms of tool use, and then context engineering, and then inference work that's going to enable like really magical consumer experiences. I'm pretty confident we're going to see cool stuff this next year.
Yeah, I agree. She said it way better than I would. I give you like quick customer anecdotes where you're like, oh, that's interesting. A company called Whisperflow, which is trying to make it really easy to interact by typing without using a keyboard. I think they're changing how people are thinking about that. I think another one is another one of my customers, a customer called Yutori, that's kind of doing offline. How would you explain it? The offline agents? Is that?
You're having like proactive like stuff come to you from the web.
Yeah. So you kind of like give a job to be done, and it kind of just comes back to you from time to time, and that's super interesting. And I think honestly, on like the music generation stuff, if you go look at one of our companies, Refusion, which is called Producer, or even Suno now, the way they are unlocking users interacting with music models is new and unique, and as models get faster, as capabilities change, I think it just unlocks new things.
Okay, I think we're being waved off. Oh, one more. If there is one more. Yeah.
I'm Winnie from HiDreamer. I'm curious, what is the biggest bottleneck right now for Baseten or for other inference companies in giving even faster inferences? Is it like hardware problems, software, talent, regulations, money?
Yeah, it's talent. It's probably talent. Everything comes back to talent to some extent. It's not,
I think it's engineering problem.
It's an engineering problem, and I think then it's probably like a. I think there's more work needs to be done at the layer like of kernels and systems to unlock those things, but I don't think it's regulation or anything like that. It will happen, and like every month everything is getting faster. It is
it's very encouraging.
Yeah, and it's also converging to some extent. I'd say I think the right now I'd say it feels like the performance stuff is pretty unlocked. Like I think we're at some point you come up against the speed of light, and like some of these models are running very, very fast, and like now it's just more about throughput and cost efficiency and all those things, and then maybe it's just more dollars is the bottleneck.
I maybe add one last thing here, where I think as the tooling and the skill set for doing distillation and RL for specific tasks and fine tuning just becomes, as all that becomes easier, I think people are going to have many more specialized models, right? And the easiest way to make a model fast is make it small. So I think we're just going to have a lot of that too. All right, thank you guys.